Example number 6 is solve the following logarithmic equation. Log x to base 4 minus log x minus 4 to base 16 is equals to 1, isn't it? So as usual, for you to solve this kind of problems, then you must have same base, isn't it? So this is base 4, this is base 16. But 16 can be written in terms of 4, meaning you don't need to take 4 to be in terms of 2, isn't it? Because 16 is the same as 4 squared, so it is in order to use base 4, isn't it? But if you had something like base 8, 8 cannot be written in terms of 4, can be written in terms of 2, isn't it? Yes. Meaning you put base 4 to be base 2 and base 8 to be base 2, isn't it? Yes. Are you seeing what I'm trying to explain? Yes. Yeah, so base 16 can easily be written in terms of 4, so you just leave it as 4 squared is 16, isn't it? Yes. So let us start. When you have log a to base b, that is the same as log a over log b. So when you have log x minus 4 to base 16, that is the same as log x minus 4 over log 16. The base is the logarithm with the denominator, isn't it? Yes. So here we have base 4, meaning here we need to get 4, isn't it? Yes. So you know 16 is the same as what? So here is log x minus 4, 16 is the same as 4 squared. 16 is the same as 4 squared, isn't it? Yes. So this power 2 becomes the coefficient, isn't it? So this power 2 becomes the coefficient, so that we have, here we now have 1 over 2, isn't it? 1 over 2, then log x minus 4 over log 4 becomes log x minus 4 to base, because the logarithm with the denominator is the base. Here we have a half, then log this over log this, meaning whatever is in the denominator is the base, isn't it? Yes. So if you go back to our problem, what do we now have? We now have here log x to base 4, then minus, we found that log x minus 4 to base 16 is the same as what? A half log x minus 4 to base 4, isn't it? So you can see on this side of the equation we now have the same base. Base 4 base. Are we together? Yes. Yes, because 16 could be expressed, factorized in terms of 4. If it cannot be factorized in terms of 4, you take everything to base 2, isn't it? Are we together? Yes. Good. Then the other side we have 1, meaning we introduce log 4 to base. A log of a number to the same base is 1, isn't it? So we now have base 4 in each and every term, meaning we can now solve that problem, isn't it? We can now solve that problem. So to solve that problem, we get rid of the coefficient first, isn't it? So here we don't have a coefficient, so we just have log x to base 4 minus this a half becomes the power of everything, isn't it? So we have log x minus 4 to power a half, then our base 4, isn't it? Then it's equals to log 4 to base 4, then this one becomes the power. 1 is silent, isn't it? Are we together? So it is that. So, one term on either side of the equation, isn't it? So you must have one term on either side of the equation. So if you factorize out log to base 4 here, subtraction implies what? Division, isn't it? So it means here we'll have x divided by x minus 4 raised to power a half, isn't it? So when you remove log to base 4 side, subtraction will go to division. To be equals to log to base 4, 4 raised to power 1 is just 4, isn't it? Then what do? Once we make log 1 on the other side of the equation, we now ignore the logs. You can only ignore the log if it is only one term on the other side of the equation, isn't it? Yes. So when you have one term on the other side of the equation, you ignore the log. So what do we remain with? X over x minus 4 raised to power to be equals to 4, isn't it? Yes. So we multiply both sides by whatever is in the denominator to get rid of the denominator, isn't it? Yes. Meaning we multiply both sides by x minus 4 raised to power, x minus 4 raised to power, so that this cancels with this, isn't it? Yes. Are we together there? Yes. So what you see here is now quadratic in nature, isn't it? So here we have x is equals to 4 into x minus 4 raised to power half. So to get rid of this power half, what do? See, we multiply both sides of the equation by 2 to get rid of this power half, isn't it? Yes. Is that okay? Yes. So if you do that, what do you get? X raised to power 2 is x squared to be equals to this power outside is for everything, isn't it? Yes. 4 raised to power 2 is 16. Then a half times 2 is 1. So you remain there with x minus 4 raised to power 1, which is just x minus 4, isn't it?
Yes.
So you think that is quadratic?
Yes.
So this is now x squared minus 16x. 16 times 4 is 64, isn't it? Yes. So it means plus 64 is equals to 0 because 16x coming on this side of the equation it becomes negative, isn't it? Then 16 times 4 is negative 64. Negative 64 coming on this side of the equation it becomes positive 64, isn't it?
Yes.
Are we together? Yes. So you use product formula or factorization. If you use product formula, if you use quadratic formula, what are the solutions? If you use quadratic formula, anybody with the 570 ES or 991 ES, will you get it on one cell? 991 ES? Okay, if you don't have that, can you use the board? Is factorization working? Oh, good. This guy is always very, very in order. He's always in order. Negative 8 and negative 8, isn't it? Good. So you have x squared minus 8x minus 8x plus 64 is equals to 0. So you have x, you factorize out, you get x minus 8. Then you factorize negative 8, you get x minus 8 is equals to 0. So here either x minus 8 is equals to 0 or x minus 8 is equals to. Are we together there? Are you seeing that? So x minus 8 is equals to 0 or x minus 8 is equals to 0. This minus this is equals to 0. So either this is 0 or this is 0, isn't it? Yeah. So it is x minus 8 squared is 0. You find the square root on both sides. X minus 8 is 0. You get x is equals to 8. X is equals to 8.